Hey y'all, so in this video I'm just starting part of our lesson 1.4 and then we're going to finish it on Friday. But in this part we're just going to focus on the concept of what we call difference of squares, and then we're going to solve quadratics where b is equal to 0, and I'll explain that, but using the square root method. So again, before we get started, go ahead and pause the video and do these two review questions, multiplying those out on your own. So go ahead and pause it and try these two. And here we go. So again, if we're just multiplying out, right, I'm going to go ahead and set up my box method. So here I've got x and then my positive 8, but x and negative 8. So when filling in, you get x squared. Here you get 8x. But now I have negative 8x, right? And here you get negative 64. So notice when combining the like terms, sorry guys, you should have noticed that 8x minus 8x is just going to cancel out and give you 0. So really you're just left with x squared minus 64. Sorry, because I had erased that negative before. So same thing here. I'm going to go ahead and set up the box. So here I've got x and my positive 9 and x and negative 9. So in the boxes here, x squared, 9x, then negative 9x and negative 81. So same thing again, right? Notice how on the diagonal, here you have 9 minus 9, which is 0. So they cancel out. And here you're left with x squared minus 81. So now notice in these expressions, what is b equal to? Well, b is equal to 0. Because remember our standard form, right, was ax squared plus bx plus c. B was always here with just our x. Well, what do you notice? We don't have an x, right? It's 0. So notice how we just have our x squared term and our c constant. And notice how both of them are negative. So here we have our difference of squares. So the difference of those squares, or difference of two perfect squares, again, right, is where b is equal to 0 and you are subtracting two perfect squares. So like, for example, if I have x squared minus 9, this is a difference of two squares. Because if I were to take the square root of both of these values, well, remember, right, if I ever took the square root of x squared, these are inverse operations. So what happens? The square and square root cancel out, and you're just left with x here. Then if I were to take the square root of 9, well, the square root of 9, remember, right, is not just 3, but positive and negative 3. So if I were to write this out, my difference of perfect squares, we would write this as x plus 3 and x minus 3. So same thing here, right? Is 16 a perfect square? Absolutely, because the square root of 16 is not just 4, right, but positive negative 4. So if you were to write this in factored form, my difference of squares, you have x plus 4 times x minus 4. So let's go through and continue on and try these. So notice how, make sure, right, no matter what, that we always first need to factor the GCF. Now in A, we don't have a GCF because my x here has just a coefficient of 1. But is 4 a perfect square? Absolutely. The square root of 4 is positive and negative 2. So how would I write this? I would write this as x plus 2 times x minus 2. So then here now, notice, do we have a GCF? Yes. Notice how between 18 and 50, let's think about that, right? What is the GCF? Well, they're both even, so I can divide both by 2. So I'm going to take out that GCF here, divide that out, and I'm left with 9x squared minus 25. Now, before we get started, do 9 and 25 have any common factors? No. So 2 was the GCF. So now do we have a difference of two perfect squares? Well, yes, because I have the square root of 9 here and the square root of 25. The square root of 9 is my 3, and here square root of 25 is 5. So now notice in the end here, right, when we're factoring, we always have our plus and our minus, because in the end they need to cancel out so that b is equal to 0. So in this case, fully factored, you have 2 times 3x plus 5, right, because the square root. So then 3x minus 5. This is fully factored form. Then the last one, notice it's just reversed, but it's all the same, right? So in the end, we're always going to have, when we're figuring and writing out our difference of squares, we have our plus and our minus here, right? So here, square root of 1 is just 1. But then the square root of 16 is 4. So here we have 1 plus, oops, sorry guys, 4y, and 1 minus 4y. So go ahead and pause the video here and try these 3 on your own. Don't forget, right? First step is always GCF. And here we go. So notice how, do we have a GCF in the first one? No, you don't. But do we have both? Are they both perfect squares? Yes, because the square root of 81, square root of 144, they are both perfect squares. So when we're writing this out, right, remember to get b is equal to 0, I have my plus and my minus. So here we've got 9x plus 12 from the square root of 144, and then 9x minus 12. All right. So then the second one, did you have a GCF? Yes. They both can be divided by that greatest common factor of 3. So 3 times 4x squared minus 9. Now here, are we left with 2 perfect squares? Yes, I can take the square root of 4 and the square root of 9. So here you have 2x plus 3 and 2x minus 3. Last one here. It's reversed, but it's no worries, right? We're going to keep it in that order. So is 144 a perfect square? Absolutely, because we even did that in A. So here we've got 12 plus x and 12 minus x. So notice how keep it in that order. So now we're going to solve our equations where b is equal to 0. But for this portion, we're just going to focus on solving by the square root method. And here we have our steps here, but I want you to think about it like this. Think about it like it's a 2-step, right? Like let's just say, like I'm going to look at example 2 because I could think about it like a 2-step. Take out that squared. If I were to solve 5x minus 125, right, is equal to 0. Well, if I'm solving for x, what would you do first? Add the 125, right? Well, guess what you're going to do first here in number 2? Add the 125 to both sides of the equation. So now you've got 5x squared is equal to 125. Now I'm going to go back up to the top here. So let's say you just have 5x is equal to 125. Well, then what would you do last up here to solve for x? Divide by 5, right? Because you're multiplying by 5. That means same thing. What are you now going to do to get this x term by itself? Divide by 5. So now I've got x squared is equal to 25. Now up above, we would say x is equal to 25, but is this our final answer? No, because see how we have a squared? So again, what's that inverse of the squared? Take the square root. So here you get x is equal to, because they're inverse operations, positive and negative 5. So now let's go back to example 1. So again, what are you going to do first? Well, I'm going to add 48 to both sides of my equation to get x by itself. And here I've got x squared is equal to 48. Now it's not being multiplied by anything. So now what are we going to do last? Take the square root. So here now, notice how the square root of 48 is not a perfect square. So we could break apart the square root of 48 by a perfect square factor, right? So I'm going to list those out so you can visually see. So that means here I could have the square root of 1, 4, 9, 16. Here for this problem, I'll stop at 25 because then I'm getting too big. But 25 is not a factor because if I divide 48 by 25, not going to work. But is 48, can I divide 48 by 16? Yes. 48 divided by 16 is 3. So now what is the square root of 16? Positive and negative 4. So positive, negative 4, radical 3. So don't forget that radical 3. So go ahead now, pause the video and try these two U-tries on your own. So in the first U-try, what would you do? Add 96 to both sides. So now I've got 6x squared is equal to 96. Then, because you're multiplying x by 6, divide by 6. X squared is now equal to 16. So then that last step, take the square root with those inverse operations, and x is equal to positive negative 4. And for number 4, here we go. We're going to subtract that 15, right? Opposite operation. So 3x squared is now equal to 20, not 24. Sorry about that. But 21. Then x is still being multiplied by 3. Divide by 3. X squared is equal to 7. And that last step, right? Because of the x squared, what do we have to do? Take the square root. So notice how you end up with x is equal to square root of 7. Well, that's prime and you can't simplify it. So just leave it positive and negative square root of 7.